Hi, folks. If you can hear me, could you give me a hi or a low in the chat? Okay, I assume you can hear me, and I assume it's 1 o'clock. So today is our last lecture before fall break. Okay, and we're finishing up week 8 homework. This particular lecture is a big one because we're introducing the second half of our class. But please notice that the homework is due the 19th and it's not due the 20th. Okay. So please notice that you have to have it done by then. Okay? That being said, today's lecture is going to be kind of heavy because we have to introduce the second half of the class. So I'm going to do the best I can to introduce the topic so you can go straight to your homework and do it. But being said, I don't know if I can actually get to everything in time. I'll do the best I can. But please notice that it's due, and many of you have already been working on it, so you're well prepared. But there's definitely a cut in about half of that homework between what this homework is over. Okay, so the second half is going to look kind of different from the first half. So please be sure that you get that done. I also know that you probably have finals in your other class. At least we don't have a quiz or a final or a big project due in this class. We just have the homework that we need to complete. Okay. I should also mention that I put a couple homework help videos, posted them yesterday. I don't know if you have any interest in them, but if you go to the announcements and you go to uh, Tuesday's session, I have a homework help video where I went over some of the homework problems, the word problems, and I posted a video there. I think I only went over like 4 problems. So if you're having any trouble from the homework, you might take a look at that and see if that helps, or just going over the homework. But I was prepared to help my online trig class. They have a final exam this week, but nobody came, so I thought, well, I'll just do a homework help video for you guys, since nobody showed up. So maybe that's helpful, but that's where that is. That was posted yesterday, so maybe that's helpful. Okay. All right. So again, the homework is going to be due Sunday and not Monday. Be sure that you are keeping that in mind, but it shouldn't be overly difficult in comparison to, having a final exam or a quiz or a project or something. All right, so today's going to be kind of weird. It's going to be different than usual. So please, bear with me on this stuff. Today I'm going to introduce trigonometry, which is going to be what we talk about for at least the next, let's say 4 to 6 weeks. We're going to be going over this. Okay. So we're going to introduce angles today. We're going to have a little bit of geometry we have to deal with. Try to not overdo it, but yeah, this is a big one. So I'm just going to make a circle, and I cut the circle in half twice, so I guess I now have quarters. So we can imagine that this is a pizza, and you can put your favorite toppings on there. But we're going to talk a little bit about circles. We talked about circles way back when. Okay, I'm actually gonna set the radius here to 1. We talked about circles, gosh, first week, second week. It's pretty early on. It was like section 1.9, I think. We talked about circles. I won't expect you to remember too much from that lecture, but x squared plus y squared plus radius squared is a circle, and we're going to talk about a very particular circle here. So x squared plus y squared equals r squared. But we're going to have our radius set to 1, and what we're going to hopefully examine today is what's called the unit circle. That's the idea anyway. Okay. What is the unit circle? Well, this is our old friend, the Cartesian coordinate system, the usual one there. Let's look at some specific points. So we have a circle on the plane, and it's of radius 1. So this is at the point 1. This is y equals 1, negative 1, negative 1. So that's the circle that we're thinking about. Right? So that's the point 1, 0 there, or 0, 1, or negative 1, 0, or 0, negative 1. That's the circle we're thinking about. We're going to try to find a whole new language about angles. Okay. I'm going to have to just pull some formulas out of thin air, ones that we learned, I don't know, grade school, middle school, high school, but a few that we need. And one of them is, do you know what the fancy number pi is? Like 3.1415269, that guy. Do you remember where that comes from? Has something to do with the circumference, has something to do with diameter. Do you guys remember what pi was? You guys do the ratio of what? Is it circumference by diameter or diameter by circumference? Anybody remember what pi is? Yes, okay. All right. Let's start here. So the circumference of a circle is 2 times pi. Pi, in my opinion, is a magic number. We've talked about magic numbers before. One of them is E. E is kind of magic. Square root of 2 is a little bit less magic, but pi is definitely. Okay. In math, we call them transcendental numbers. Okay. They're almost outside of algebra. And pi is something that has to do with all circles. Okay. Not just this unit circle, but all circles have this ratio about them. So if it's a perfect circle, it has something to do with this ratio. Okay. Something very special. Okay. And the circumference of a circle is 2 times that number. Okay. So what is the circumference? I shouldn't assume anything. So their circumference is all the way around. Okay. Circumference is all the way around. How long is that? So if I took a piece of string and I went around my water bottle, and then I took that string out, that's how long the circumference is. Okay, it's wrapped around the circle, however long that is, that's the circumference. It's the length. If it was a rectangle, we call it perimeter. Okay. So that's the idea. That's the circumference. Okay, so the circumference is coming from this pi business, and it's 2 times pi. All right. And I've cut the circle into quarters here. So if the whole circle is 2 pi, then how much is just that? How much is just the top half? If the whole thing is 2 pi, then how much is half? 1/2 of the circumference is 1/2 2 pi is pi. Okay. So if I'm just looking at the top half, how much is that circumference? It's just pi. Okay. So the top half is just pi. Right? Sure. So if that's true, how much is just this? I'll switch colors. How much is just this guy? The whole thing is 2 pi. Then the top part is just pi. Then that quarter, yeah, Michael, it'd be 1/2 pi. Sometimes they call it pi halves. It's just 1/2 of pi. Okay. So that's what we're thinking. It's a very specific circle. It's of radius 1. It's centered at 0, 0. Okay. The circumference is 2 pi because it's a perfect circle. Half of it would be the circumference of pi. The quarter would be a half. Okay. All right. What about right? Let's draw it correctly. There's a really special spot I want to get to right here. Right here is halfway between there. Okay. X equals 2 pi if radius equals 1. C equals 2 pi if radius equals 1. Yeah. Okay. So the whole thing is 2 pi. You cut it in half, you get pi. You cut it in half, you get half of pi. You cut that in half, you should get pi over 4. 1/4 pi. That's the idea. All right. This particular spot I'm thinking of is halfway between X and Y, equal. Okay. This distance here and this distance here, what I want is them to be equal at this spot. Whatever that location is, that's where I want it to be. I want it to be where it's equal. It's half. I cut that sector in half. Okay. Where is that? Where is that located? So there is some X value and there is some Y value right there. And I need to figure out where that is. Okay. What I'm going to do is I'm going to walk you through it. And then once I walk you through it, we will just say that's the truth. Okay. I'll also show you how to find it on a calculator in multiple different ways. But I'm going to walk you through where is that X and Y. Right. In fact, there's 3 values in this piece that I want to walk you through. Once you understand what those 3 pieces are, you'll understand the entire circle and maybe the entire subject of trig. So I want to kind of really focus on this piece for a second. Okay. So I need to kind of walk you through a difficult subject for this one because I think you might get something out of it. I think. Okay. So what am I looking at? I'm looking at this triangle right here. Right? Let's look right here. I'm going to rewrite it. That's not so good. I'm going to remember where the dead spots are. Okay. So I'm looking at that triangle. I want this point. That's what I want. I know that's radius 1. I drew a right triangle. Okay. So there's some length here. There's some length here. And I want to know what those are. I'm trying to figure out where the location is for X and Y. Where is this on this circle? Now remember, we have X squared plus Y squared equals 1. At this point, wherever that point is, this particular point is of equal distance between the y-axis and the x-axis. Okay, it's in the first quadrant. This is quadrant 1 in the dead zone of this TV screen. It's in quadrant 1, so they'll both be positive because they're in quadrant 1, right? Whatever that x value is, it's positive. Whatever that y value is, it's positive. I don't know what the number is, but I know they're positive. Okay, so I know that. I know they're equal distance. Okay, from those ideas, I claim whatever they are, whatever that value is, they have to be the same. For that location, that particular location right there, whatever the value of x and y is, it has to be the same value because they're of equal distance of x and y. They're at some location and they're stuck on this circle. They're both positive. They have to be the same. So whatever they are, x equals y. It has to. So if that's true, and I believe it is, then we can actually solve for what that value is. So we have x squared plus y squared equals 1. We're on the circle with radius 1. Okay. So I think we have x squared plus x squared equals 1. They're the same. They are the same. Okay. So Michael asks, if radius, only if radius equals 1, when we learn about the unit circle is of radius 1, okay? If it was of radius 2 and we redeveloped trigonometry, it would be slightly different, okay? It would be a different value. Wait, maybe I'm overreaching on what you wrote. You said only if r equals 1. Rules only work for unit circle. What rule? I don't want to overly answer your question. I don't want to answer something that's not there. C equals 2 pi if radius equals 1. That's true all the time. I mean, that's the circumference of a circle. Okay, so if they're at this position, I think they have to be equal, whatever that is. These positions are on the unit circle. X squared plus y squared equals 1. Okay, that means they're the same. So I'm just going to say that we have x squared plus x squared equals 1. They're the same, whatever that value is. Now I can solve for that value. Okay, so I have 2x squared equals 1. Okay. And after going through all this algebra, I know how to solve that. Okay, so that implies that x squared equals 1/2. So what is x? Well, that means that x equals 1 over root 2. I know it's not negative because I know I'm looking for a point in the first quadrant. Okay, I know where I'm looking. So it must be 1 over root 2. That is the value for the x, right? So now we know what that is. Often written as root 2 over 2. Okay, so it's the same value, but usually we write it with a rationalized denominator. I claim they have to be the same value because of that location, very particular location. Where was that location? It was a quarter of the way. So it's in the first quadrant. It's at pi over 4, and that's where it's located. In trig class, we'll call this pi over 4. That's where it's at. These are called radians, and I'll go over that more and more and more. But this is at pi over 4, that location. Okay? So if you believe me, we don't have to go through that proof again, and you don't have to go through it. It's done. Okay? The proof is in the book. The proof is online. It's on YouTube. It's on whatever you want. You can ask your favorite AI, and it'll give you the same answer. It's been well known for a long time. But what else can I say about it? I think I actually know quite a bit more than just that point at this moment. I mean, a circle is pretty symmetrical. I think we could say that. I think it could be said that it is a very symmetrical shape. Okay. So there is a point over here which is roughly the very same. Okay. So over here, there's also that location. But it's in quadrant 2. So it's not going to have the same sign. Okay. This is quadrant 2. And so the x would be negative, but the y would be the very same. This is negative root 2 over 2. This is positive root 2 over 2. Okay. I think there is a spot down here which is the same. Right down here, or you could think over here, it's the same. But it'll have a different sign. This would be negative root 2 over 2. Negative root 2 over 2. And there's another one. It's right here, or you can think it's right there, or you can think it's right here. I mean, it's right there, right? There's another spot which matches up with these. This is at positive root 2, negative root 2 over 2. This is in quadrant 4. So 4 spots. I mean, it's a circle. It's pretty symmetrical. So if we can figure out one, we kind of get 3 others for the same price. Okay, so that's kind of nice. All right, I haven't told you what those angles are yet. I'm going to, but I just wanted to show if you figure out one thing on the circle, you figure out a lot. Okay, because there's so much symmetry going on at once. Okay, so the whole point of this slide right here was to introduce the unit circle, which is what I'm trying to do, and to find the location at pi over 4. Those are the 2 things I'm trying to do right now. By doing that, I also find 3 other points just by changing the sign. Okay, I'm going to go over this all again in a different way, but this is the introduction of it. Okay, once we have these points, we don't have to find them again. They're always there. They're always there. They're already in your calculator. They're already in your homework. They're already on your test. They were before you, they'll be after you. Okay, that is the location at pi over 4 on the unit circle. Okay, all right. I need one more point. I need to walk you through one more point, and then we'll have the whole unit circle. Okay, so I need to walk you through one more. But let's write down at pi over 4, we have root 2 over 2, root 2 over 2, and hopefully I didn't lose anybody at this step, right? You have 1 over root 2, and a lot of times people want to rationalize the denominator. So you have root 2 over 2. Now, I personally don't care if you write 1 over root 2. I've had textbooks write that. It doesn't bother me. But some homework systems get really bothered if you have the square root at the bottom. Anyway, so we have pi over 4, pretty sure. Pretty sure we have it. Okay. Again, I need one more point on the unit circle, and if I can get that point, I think I can actually understand the whole unit circle. All right, so if you will afford me setting up again, I'm going to find one more point in the unit circle. Let's cut it in half. Cut that in half. Okay, and I'm looking for this time. Well, there's 2 points here that I'll get. If I get one, I get the other one for free. I'm going to cut this into thirds. Okay, so I'm going to cut it into, well, I guess 6, right? If we cut it that way. Let me clear this up so you know what I'm talking. However, so I want to find pi over 6 and pi over 3. I want to find these. If I find these, I'll have the whole unit circle. Okay. How do you find those? To find those, this is the harder one. And if I find one, I get both. To find pi over 6 or pi over 3 is harder because I don't have that equidistance that I can count on. So I have to do something else. And I'm going to invoke our old friend Pythagoras to help us with this one. Okay. Stupid TV screen. Okay. I'm going to try to find pi over 6 and pi over 3. These aren't drawn terribly great, but I'm going to try to find them. So this is at pi over 6. This is pi over 3. Okay. But to do this, I'm going to have to call my friend Pythagoras to be able to do it. Let's see. Draw a triangle. Okay. Let's say that that is pi over 3. Let's say that that is a right triangle. So I'm trying to get this triangle here. And of course, I can't draw it on the TV screen because it's broken. But I'm trying to get that triangle. So I have a right triangle, pi over 3, and a 90-degree angle there. Okay. Let's call this A. Let's call this B. Let's call this R. I know what R is because it's on the unit circle. Unit circle is x squared plus y squared equals 1. So we know what that is. We know that's 1. Okay. if I know I have a 90-degree angle, I have pi over 3. What is the missing angle? That's on my mind right now. And how am I going to find the location? This is the whole point. What is the x and y right there? And what is the x and y here? That's what we're trying to find. Pythagoras said that the sum of the squares is the hypotenuse squared. So this is a right triangle, so it applies. All right. But I don't think I can get it from there. I don't have enough information. I'm going to do a trick. And the trick is to get this stupid thing to work. I'm going to draw an identical triangle right there. Okay, which would also be 1. And would also have an A. So I have like a mirror of a triangle there. Pi over 3 is the one I'm looking for. I promise you, if I can get pi over 3, I get pi over 6 for free, which is nice. So what does that mean? This triangle has to have the same angles as the other triangle, right? Right here, those have to be the same. Those A's, whatever that length A is, they have to be the same. Those two A's have to be the same. It's the mirror image of that. Okay. So in this case, since those have to be with the same angle, whatever that angle is, and those A's have to be the same, and if I have this big triangle with including the mirror image, I think those two A's have to add up to 1 as well. I think it's going to have to be an equilateral triangle. It's going to have to be the same. If that's true, then I have A plus A equals 1. 2A equals 1. A equals 1/2. If that's right, then a single A is 1/2. Okay, so then this is 1/2. Let's see where we are now. So if this is 1/2 and this is 1, this is 90 degrees and this is pi over 3, we haven't determined what that angle is yet. We have some unknown height. Okay. But Pythagoras is here for us. Okay. A squared plus B squared equals C squared. I know what C is, it's 1. I think A is 1/2, so I can solve for B. Okay, so A squared plus B squared is C squared. It is a right triangle. It has a 90-degree angle. I think A is 1/2, B squared, C is 1 squared. B squared equals 1 minus 1/2 squared, which is 1/4. So I have 1 minus 1/4, 3/4. Okay, B squared is 3/4. So what's B? If we take the square root of B, we know it's in quadrant 1, so it has to be positive. B has to be square root of 3 over 2. So I think that's the location of pi over 3. There's a question in the chat said, how did we find the value of 2a? Are we okay with the symmetrical triangle, the mirror image triangle? Was that okay? That part's okay? Okay. So I set whatever this value is, whatever that value, whatever this value is, I think they have to be the same. Because I want just a copy and then to invert the triangle. So I think I'll just call it A, whatever that length is. And then looking at this triangle, now the big one, now I have a big triangle. So I have this one, and I have pi over 3. I have pi over 3. I have 1, 1. Whatever this is 2a. And whatever this is, it's half of what I had before. And I think the only way this works is if 2a equals 1. I think it has to be an equal out triangle. I think it has to be 1. And if 2a equals 1, then 1a would be half. So a equals half. I think that's why a equals half. But if a equals half, okay, now we can start talking b. I think a is half. And if Pythagoras is right, c is 1, a is 1/2. So b squared equals 3/4. B equals √3 over 2. So that's the location of pi over 3. It's 1/2 √3 over 2. All right, that's the location. I promise if we figured that out, we get pi over 6 for free. Okay, let's see how I do that. Let's see if that's even true. So this whole thing was to get the location of pi over 3. All right, what was this missing angle that I didn't talk about? A triangle has to equal 180 degrees, or pi. That's half, right? So a triangle, 180 degrees equals pi in this world, okay? The whole triangle, the right triangle at least, has to equal pi, okay? It has to. I have a missing angle here. Pi equals pi over 3 plus pi over 2 plus, I don't know, somebody else. But it has to add up to pi, it has to add up to 100 degrees. Okay. So what's that angle? Who's this? Okay. So pi minus pi over 3 minus pi over 2 equals mystery angle. Well, let's figure out how we can do fractions. Let's make these a 6, I guess. I don't know. So I could double this to 6. That's 3, 6. And that'd be 6 over 6. Just doing the arithmetic. So this is pi over 6, the missing angle. Missing angle was pi over 6. So I said if we could do this, we get the location of pi over 6 for free. So you have root 3 over 2, 1/2, and 1. This is pi over 6. This is pi over 3. We only need to switch them, okay? We only need to switch them. This will become root 3 over 2, and this is 1/2. So we're looking at the angle, the other angle, top angle. We're looking at this angle now. So if we want to evaluate that, that's root 3 over 2 for the x and 1/2 for the y. It's inverted. Okay. We're going to see this a lot. We don't have to prove this again, but we'll see it a lot throughout the semester. So I claim we now have 3 positions in the first quadrant. Okay. So that's pi over 4, pi over 6, pi over 3. If you know those, it's symmetrical along the circle. So you get copies of that all around the circle. And those are the only ones we need to know for the course. Other than that, we can just use a calculator. Okay, let me check my time. We're okay. So I'm going to fill in the rest of the circle. Okay, I'm going to clear this. And I'm going to fill in the rest of the circle. Go here, and pretty sure we got this one. This was pi over 4. This was pi over 3. This was pi over 6. Okay. So who are those? This is root 3 over 2, 1/2, root 2 over 2, root 2 over 2, 1/2, root 3 over 2. And we know this for free. This is just 1, 0. This is just 0, 1. We know those. That's easy. I also know this one over here. -1, 0. That's easy enough. And I also know this one. 0, -1. Those are easy. Again, this is the unit circle. X squared plus y squared equals 1. Unit circle. That's what all this is based off of. All right, so I claim you only need to memorize the first quadrant. Everything else is just symmetrical. Okay, everything else is just symmetrical. I'll need to walk through and figure out where those positions are, but this is all symmetry. So all of those have pairs over here. I'm going to do red. So there's one here for pi over 4. There's one here for pi over 4, and there's one here for pi over 4. And they're all the same value, whatever that ugly value is right there. Can't read. All we have to do is change the sign for whatever quadrant we're in. We know those for free, but we should probably figure out who those are. This is pi over 6, pi over 4, pi over 3. This is pi over 2. This is pi. This is 0. And we'll figure out the rest. Now pi over 4 is easy. It's the easy one. Makes it negative over here, positive here, both negative. And the x is positive, the y is negative. Okay, but we need to figure out what we are. All right, so where is this quadrant 2 pi over 4 business? Quadrant 2 there. A better teacher than me once showed that you could do this. Maybe you'd be interested. This would be 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4. You can just count them. 1 pi over 4, 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4. You can just count them. So I think that's 3 pi over 4, but I can also show you that. This is 3 pi over. Okay, that's what I claim. But you can also just use arithmetic to find it as well. So we know that it's pi over 2 plus pi over 4. It's pi over 4 plus straight up. So you can just add them. And what's this? If I double this, turn that into a 4, 3 pi over 4. So you can use arithmetic or you can just count it however you want, or you could use a different method. And you'd be fine that way too. Okay, so if this system works, see how I keep going. So this was 3 pi over 4, 4 pi over 4, 5 pi over 4. Okay, I think this is 5 pi over 4. 5 pi over 4. But I can show you that through arithmetic too. So this is pi plus pi over 4, 4 pi over 4, 5 pi over 4. So I can either just count on the circle or I can add it up, however you take it. I got one more. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. 7 pi over 4. Let's see if that's right. 5 pi over 4 plus pi over 6 pi over 4. 3 pi over 2. So we could say that's 3 pi over 2. Okay. If I do 3 pi over 2, it's pi over 4. I get 6 over 4. I get 7 pi over 4. So you can count the circle or you can use arithmetic to find the rest. And then you would get 8 pi over 4. 8 pi over 4. 7 pi over 4 plus pi over 4. 8 pi over 4. 2 pi. We're back again. We have spun around the circle. It's 2 pi, just as we started with. So you can go around and around and around. All right, so I claim you can just count it. So that's the pi over 4s, but we also need to do the pi over 6s and 3s. All right, so I think we have the pi over 4s counted. We've counted them. So we should do pi over 3 and pi over 6 next. And those are so interrelated. We might as well do them at the same time. Okay. All right, can I clean some of this up so I have room? Okay, let's figure out this. Can you save it? I have all my notes posted if you want to look at those, or um yeah, the notes are already posted. Um if you want to look at them. And this is being recorded. I'm inside a video right now. So we can look at it again. All right, let's figure out pi over sixes. Let's also do a different color. So it's gonna be one there, be one there. Okay. So where are we? That's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So that was 1 pi over 3, 2 pi over 3, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. You can just count them. Okay. All right, that makes pi 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, exchange this dude. What did I say? 9 pi over 6, 10 pi over 6, 10 pi, 11 over 6. There she is, the unit circle. All right, now I need to fill in those locations, which we already figured out. All we need to do is switch out the signs. So this is still positive, but this part is negative because we're in quadrant 2, of course. And this is the same thing, except it's negative. Okay. And this is the same thing, except they're both negative. And this is the same thing, except they're both negative. And this is the same thing, except that part is positive. And this part is the same thing, except that part is negative. And there it is, the unit circle. Behold, the unit circle. And I shouldn't even bring it up. I have no idea why. Those are the ones we do, and we don't do anymore. We don't do pi over 5. We don't do pi over 7 or pi over 13. I'm not sure why, but nobody does, so we won't either. You can do pi over 5, but nobody ever does. Okay, so we won't either because it's an even harder thing to get, but you can certainly get it. Okay, so these are the ones we need to know. Again, I claim the only thing you need to know is the first quadrant. Okay, the only thing you need to know. You said, could you? Yeah, you can. You definitely can. Um, but we don't, and I don't know why, but we don't. Okay, so we don't do pi over 5. We don't do pi over 7. Um, but you could. You could. I think so. The only trick with finding it exactly, is more and more and more triangles, pretty much. Okay. But if you want other points, then we might ask TI-83 what it thinks. Okay. So we can ask it. All right. Again, I claim you only need um you just need the first quadrant. Okay. We just need the first quadrant. Okay. If you under if you understand this, that's all I need you to understand. I just need this. It's symmetrical, so we just need this. Yeah, it's symmetrical. So this is 0, 2 pi. This is pi over 6, pi over 4, pi over 3, pi over 2. This is at 0, 1. This is at 1, 0. This is root 2 over 2, equivalent. This is 1/2, root 3 over 2. This is root 3 over 2, 1/2. Everything else is just symmetrical. They all have pairs and family and cousins, right? They're very symmetrical. That's the only part you have to understand. From there, I mean, it's nice to know that that's pi and that that's located at -1, 0. And then down here, you have 0, -1, got 3 pi over 2. That can be nice, but you really only need to truly memorize the first quadrant. That's the one you have to know. You have to know the first quadrant. Now again, why don't we go over pi over 5? Why don't we go over pi over 8 or 7? I don't know. I don't actually have an answer. Um, but we don't, so we won't. Okay. Now, I've been using this language like 2 pi, pi, pi over 2, pi over 4, pi over 3, pi over 6. Okay. You can look these up on the calculator as well. Okay. You can find those locations using the calculator. In fact, I have a calculator right here. We can ask. Here's the price of asking the calculator. You have to be in a particular mode. Or if I was making a joke, the calculator has to be in a particular mood. It has to be in the radian mode. Radian mode is what we're talking about. Okay. If it's in degree mode, it's thinking about something else. We need to be in radian mode. Okay. I believe that's true on other calculators too, not just this one. Trigonometry. What mode am I in? I'm in degree mode. I want to be in rad mode. radian mode is what we're thinking of. Sometimes we talk about degrees. In fact, if you become an engineer, you'll most likely focus on degrees. We'll go back and forth. Okay, we're gonna go back and forth in this class to degrees and radians all the time. But right now, for this hour, we've talked about radians. So anyway, we can ask this a particular. If we ask it right, it will give us this value. So let's say I want, what is the x value of pi over 3? I can ask this calculator that question, but I have to know how to ask that. All right, so I'm going to use the COS function and say pi over 3, that's what I want. This is me knowing how to ask it. This is the x value, and it's 1/2, 0.5. I can convert it to 1/2, but that's what I'm asking. Over here, if I want to ask what is the y value of pi over 6, again, you have to know sin function, pi over 6. We're going to go over what these functions mean, but this is how you can ask it. 1/2. All right, so just have to know how to ask it. Root 2 over 2, it's going to give it to us, but it's going to look ugly, right? So the COS function of pi over 4 is this guy, which is root 2 over 2. That's the idea. Or you could ask, what is the x value of pi over 2? COS 0, as we predicted. Or over here, 0 over 2 pi. 0. 1. Or 2 pi is 1. Hey, what is it for 4 pi? Same number. Just went around again. All right. I feel gross calling it COS function, SIN function, but I haven't taught you what those mean, so I needed to not use their name. Okay. So this is the beginning. This is the beginning. This is the unit circle. Now you've been introduced to the unit circle. This is what we're looking for. We're looking for the values on the XY plane where these things are true. Okay. But the calculator is nice enough. We can plug in anything on that unit circle and it will tell us a value. Okay. So this is the beginning. Is there anything else for this part that I can go over? Checking my notes. Checking my notes. Checking my notes. Yeah. That's the unit circle in my opinion. So we need to talk about what is COS and SIN. We need to talk about them. That's going to introduce triangles. We'll talk more about quadrants, more about those functions, introduce new functions, and look at the homework. Okay. All right. So let's take a break. Let's come back in, I don't know, 15 minutes. Let's come back at 2:20. And we will talk about those things. All right, I'll see you then. Okay, if you're back, could you give me a hi or a low in the chat so I know it's working? Cool. Okay. We need to go over material from 5.2, but we almost bumped up against it first hour. So I was mentioning the SIN function, the COS function. We need to figure out what that is. This is coming from 5.2 in our book, but you can learn this first and then learn the unit circle second. Um, Sometimes you do one or the other. I want to draw a triangle board, please. Okay, this is supposed to be a right triangle. We have some angle here. I'm going to call this angle beta. It's like an O. It has a little curve to it. It's the Greek letter theta, and it just means angle. It's just the angle. It's just the angle. And then we have this little box here, and that means it's a right triangle. Okay. All right, now we've talked about Pythagoras. Pythagoras said that if it's a right triangle, then a squared plus b squared equals c squared. So in general, this was a, and this is b, and this is c, and that's true. And the sum of the angles have to equal 180 degrees or pi. That's the deal. Okay. All right. Now, sometimes people don't call them A, B, or C. They say that this is the hypotenuse, this is the adjacent side, and this is the opposite side. It's very common for books or teachers to say that. I don't know why. I never really liked this method, but a lot of people do, so I'm going to teach it. Okay. I never really got along with this method, but a lot of people like it, so I'm going to teach it because a lot of students like it. All right, so we have some angle. We have the right angle there. All right, all of the angles add up to pi, and we have an adjacent side to the angle. We have the opposite side of the angle, and then we have the hypotenuse of the triangle. Okay. There's a thing called the sine function. The sine and the sine of theta is the opposite divided by the hypotenuse. It's defined as this. It's one of its definitions. For a right triangle, it's defined to be the opposite over the hypotenuse. Okay, this is the sine function. So the sine, I just think it's funny how all this adds up. So why is it called sine? What does that, what does that mean as opposed to just a triangle? I looked it up. I looked it up last year because I had dealt with this for decades, and then I was like, where does the name sine come? It was one of those things like I know I should know, but I don't know. And I looked it up, and it's actually a mistranslation from one language to the other, to the other, to the other, to the other. And it was a word that was like close enough, meaning, well, meaning that. But the word sine came from sinus, which meant hollow, which was close enough to something else. And so actually it's kind of a nonsense word, which is kind of funny that all of this is based off of a nonsense word. So the sine function is just this. Okay. So it doesn't really mean anything other than that. So it's opposite over hypotenuse. Now, The sine function has someone that's very related to it, family member, called the cosine function. And that would be the adjacent over the hypotenuse. These are very related. We will see how related these are when we come back from fall break. But I can actually make the cosine function out of the sine function. That's how related they are. Okay, but right now we'll just say it's the adjacent over the hypotenuse. Okay, great. There's another thing called the tangent function. Or let's not even call it functions because we're not in functions right now. It's a ratio. Say it's a ratio. The ratio of tangent for the angle theta is opposite over adjacent. So it's the height over the length right there. Opposite over adjacent. There's another thing called the cotangent. And it's basically the same thing except it's the opposite. It's the adjacent over opposite. So it's just the length over the height. That's the cotangent. I got two more. There's 6 of these things. The secant means to cut. It means secretly to cut. We'll talk about who it cuts through later. But right now, the secant of theta is 1 over the cosine, or you could say it is the hypotenuse over the adjacent. That's the secant. SOHCAHTOA. Let me get, there's 6 of these guys. Let me get to this. This is the cosecant. Okay. Cosecant theta is 1 over the sine function is hypotenuse over the opposite. Michael says we could think SOHCAHTOA. SOHCAHTOA. Okay. What does SOHCAHTOA mean, my friend? Is it sine is opposite over hypotenuse? Cosine is adjacent over hypotenuse? Tangent is opposite over adjacent. SOHCAHTOA. Okay. I didn't even have to bring it up. You brought it up. Yeah. Sine, cosine, and tangent. There it is. Okay, there's six trig functions. There they are. Got them. Okay. So we have them all now. Great. SOHCAHTOA. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay. Now I learned this semester that not all countries go over cosecant. And I want to say they said cotangent, cosecant. So I was at a math conference, which sounds fancier than it was. It wasn't a big one. And there was some mathematicians one was from Poland, and one I think was from Russia. And they were talking about that in other countries they just don't even go over them. You can get by without them, and that's fine. My calculator doesn't have them. Okay, so I don't have a cosecant button. I don't even have a secant button. Okay, I can find it, but it's not there. I do have sine. Sine you have to have. Okay, The whole thing is built as a sine. Okay, everything. If you give me sine, I can actually make cosine. I'll prove that to you after fall break. So I have sine, I have cosine, and tangent. It's very convenient to have those. Other than that, I can get the others from those. If I have those three, I can get the others. In fact, I claim if I have sine, I can actually get by with the others. Okay, I can make the others from sine. Okay, so that's what's going on. Right now, I don't like opposite over hypotenuse. I'm not even sure why. It just, for some reason, didn't click with me. It didn't make sense to me when it was taught to me. So if you're okay, I'm going to go over this all over again, and I'm just going to use A, B, and C because for some reason that when I learned it, it made more sense. And just in case you happen to be in that camp, we can be in that camp together. So I had to learn the other way, the adjacent opposite hypotenuse way, because I started teaching and students were like, well, I like this way. I thought, uh-oh, I don't. Let's just call it A, B, and C. Okay. For some reason, this just clicked with me. I don't know why. When I was in trig, this just made more sense. So this is how I learned it. So the sine of theta is just, let's hope I don't write it down wrong. B over C. Cosine is A over C. Tangent is B over A. And then the cotangent is flipped upside down. Secant is 1 over the cosine, so it's C over A. And the cosecant is 1 over the sine, so it's C over B. Same thing. A squared plus B squared equals C squared. Okay. Now, that's how I know it. And then there's all kinds of other ways that people talk about. Okay. So sometimes they don't like this. Sometimes they say, well, that's not a C, and that's not an A, and that's not a B. You should call it an R, an X, and a Y. And I guess you can do that too. Right? And for all A's, you have X. For all Y's, you have, or I'm sorry, all B's you switch with Y, and all C's you switch with R. Okay. These are all meaning the same thing. It's all the same ratio, but different reasons for different things. The X and the Y is probably beneficial for us to have because we're going to talk a lot about X and Y, especially when we get algebraic with all this stuff. This would be X over R. This would be Y over X. And this would be X over Y. This would be 1 over cosine R over X. And this would be R over Y. Okay. So it's all the same thing. It's all the same triangle. Fine. No problem. All right. From there, we could get into what about the other angle? I don't think there's any homework problems that talk about that. But it's a big problem when you do. If you start going over this angle, then you have to rearrange all of your trig functions to be able to give you an answer for that. That's a huge issue. Maybe I'll write it down for you. In case you're interested. I guess I'll just have to erase all of it. So the sine of this guy is the opposite. Okay, and I don't think there's a single homework question that asks this, but just in case, the sine is now the x. If you want to do this angle, you have to flip it. Cosine of top angle is now y. Tangent, this angle is now x over y. Cotangent of this angle is y over x. The secant of this angle is now r over y. The cosecant is now r over x. I don't think there's any questions on the homework which asked you to figure out that angle, but just in case, there it is. Just in case. We might look at the homework together before the end of class. All right, so that's the introduction to the 6 trig functions. The most important one is ones we went over. Most students prefer the adjacent opposite hypotenuse, so that's why I go over it. It seems like I have less and less students every time I look over. Do you guys want me to keep going? I noticed that you're the ones that stayed, but okay, there's less and less, so I'm worried maybe you guys don't care. I don't know. Let's at least go over. I have to go over the Pythagorean theorem again before you go. Better do that. And there's something out of the book I need to go over. And I need to go over. Yeah. Okay. So I'm gonna talk about Pythagoras again. I don't know what you know about Pythagoras, but I've read quite a bit about him lately. And the more I learn, the weirder it is. But obviously, Pythagorean theorem. Okay. What he's most commonly known for, right? It's very strange. It seemed like he was running a cult based on mathematics, which is pretty weird. He also had rules about food and he had rules about all kinds of things. But Pythagorean theorem is true and he still gets credit for it. Okay, so this is supposed to be right triangle. This is theta. All right. Now, Pythagorean theorem, we learn it a squared plus b squared equals c squared. I think, that formula was even in cartoons and sitcoms when I was a kid. I mean, it's just one of those y equals mx plus b. Sum of the squares is the square of the hypotenuse. It's just out there in the zeitgeist. All right, but then we're also talking about sine and cosine. Sine theta is y over r, cosine is x over r, and tangent is y over x. So how do these things meet? How do they meet? Well, in the unit circle, which is what we go over, the unit circle radius equals 1. So that means that has a lot of consequences. So sine of theta is y because the radius is 1. Cosine is x. Tangent is y over x. If that's true, and it is true, then it has some pretty big consequences. That means that the sine theta squared plus cosine theta squared equals 1. That's just the Pythagorean theorem written with these functions. It's just rewritten. But it's really important and we use it all the time. In fact, you're going to use it in your homework. I think it's the second to last question. Maybe we should go over it together. But we're going to use that. Okay, we're going to use this. That's just rewriting the Pythagorean theorem with this language. Okay? How it's usually written, the notation that's usually written is this. That means sine times sine plus cosine times cosine. But that's just rewriting the Pythagorean theorem. I'm just rewriting it with sine and cosine. Okay. We need it. We're going to use it all the time. It's really helpful. It's true. So it's really helpful. So not just to answer homework questions, but it's true and it's really helpful. So we need that one. Okay. Since that's true, there's a couple more that we could go over. I don't think we need it for the homework, so we can shove it off for another time. But you can also write tangent squared of theta plus 1 equals the secant squared of theta. This is also true, but I don't think we need it for this week. It comes exactly from this. It's a consequence of this. Okay. Since tangent is the ratio of sine and cosine, and secant is the inverse of cosine. I'm sorry, it's the 1 over cosine, inverse ratio. That comes from there. I don't think we need it. We need this one, though. We need this one. Right, and I'll show you which homework problem we need. So we need to go over that. Since y is getting mixed up with sine, x is getting mixed up with cosine, I think we should go over some positive negative rules as well. Let's go back to this. We don't really need to pull out all of our angles, but we need to talk about when they're positive, when they're negative. And this is going to have huge consequences later. Okay, so we call this quadrant 1, quadrant 2. Call this quadrant 3. This quadrant 4. Now, we already talked about this, but in quadrant 1, everybody's positive, right? The x, the y, they're all positive. So over here, right, x is positive, y is positive. They're all positive. So sine is positive, cosine is positive, and tangent is positive, which is the ratio of the two. Quadrant 2, not everybody is so positive. Sine is positive, and that's it. Cosine is negative, so tangent is negative because it's the ratio of the two. Over here, sine is negative, cosine is negative, but since tangent is the ratio of the two of them, and they're both negative, that makes tangent positive. And then here in quadrant 4, let's see, sine is negative, cosine is positive, and tangent is negative. Okay, so over here, we found that all of them are positive. Over here, we found that sine is positive. Here we found tangent is positive, and here we found only cosine. So here comes another one. All students take calculus. Tells you when they're positive. Okay, all students take. We always go counterclockwise in trigonometry. All students take calculus. Okay, and that tells you which ones are positive. Okay, all students take calculus. All of them are positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. Cosine is positive in quadrant 4. All students take calculus. I can't remember if there's any problems about domain and range of these guys. That seems more applicable to what we do when we come back. And even in odd properties also seems like it would be more of something we would do when we come back. When we come back, we're going to talk about the graph of these functions. I don't remember if there's any problems where we need to do that. I don't think so. Okay. Well, let's review what we did because we've done a lot. Unit circle. We need to know first quadrant. Okay. Which would be 0, pi over 6, pi over 4, pi over 3, pi over 2, pi, 3 pi over 2, and 2 pi. If we know those, we know everything. Okay, so we need to understand those. We did triangle, x, y, r. So now we have sine theta, cosine theta, tangent theta, secant theta, cosecant theta, cotangent. Pythagorean theorem, x squared plus y squared equals r squared. So we have sine squared theta plus cosine squared theta equals 1, which is just the Pythagorean theorem rewritten. What else do we go over? That's what I remember. Okay. Two things that I never mentioned. Terminal points. Fancy way of saying like the sine of pi over 4 is root 2 over 2. The cosine of pi over 3 is 1/2. Okay. Terminal points. We didn't do that one. So now you have that. And then what do they call it? Reference number. It's kind of sneaky. Reference number has to do with the angle which is closest to the x-axis. Let me write that down. So if you're here, you would just state the angle. But if you're all the way here, you might talk about that angle, and that's confusing, okay? So there's going to be a few where sometimes you need to give a negative angle, and that's kind of confusing. So let's talk about circle again. Again, if it's just over here, it's not so bad. All right, let's say this is the pi over 4 over here. So how did I do that? 1 pi over 4, 2 pi over 4, 3 pi over 4. Okay. So the reference number for this is just that. Okay. No problem. But sometimes when you're over here, it's actually closer to just state there. So it's kind of sneaky. I wish it wasn't in this week's homework, but it is. So you might see a little bit of that. And then there's another problem where I'm going to need to do some algebra for you. Okay. All right. So what? It's almost 3 o'clock. Thank you for those that have stayed. Understand you probably didn't want to. But I do appreciate you. Okay. Let me at least do these 2 problems, and then we'll see how you're feeling. Okay. Let me talk about this one. So this is question 36 on the homework, right? Sine and cosine. And it wants write the first expression in terms of the second. First in terms of the second. My first is cosine. And they're using t. Fine. The angle is t. Okay. And then sine is the other one. So they want almost the opposite of how I think about it. They want they want the first expression in terms of the second. So sine. Okay, fine. How do you do that? And they want it in a specific location. They want it in quadrant 2. This is going to have to just do with positive or negative numbers. So where does this come from? This comes from the Pythagorean theorem. Equals 1, okay? We're going to rewrite cosine in terms of sine. Cosine squared equals 1 minus sine squared, okay? So this implies that cosine equals plus or minus root 1 minus sine squared theta. But they want it in quadrant 2. They want it, at least they wanted mine in quadrant 2. If they want yours in quadrant 3, you're going to have to figure it out. If they want it in quadrant 4, you'll have to figure it out, okay? Or quadrant 1, it's positive, right? But here they want quadrant 2. All students take calculus, right? All students take calculus. So this means the cosine is negative in quadrant 2. We want the negative one. So it's negative root 1 minus sine squared. But if they want a different quadrant, then I have a different sign. I have to know what it is they're talking about. Okay. So I thought maybe we'd go over that problem. I'll take a screenshot of it. Take a screenshot. Okay, cool. I also want to do the last, or problem 37. I'm going to go over this one. I'll take a screenshot when I'm done with this one as well. Find the values of the trigonomic functions of t for the given information. The terminal point t is in quadrant 4. Quadrant 4. So we're looking at like this. Not drawn very well. It's like that, sort of. They said the sine is negative 12/13. Sine of theta is negative 12/13. Okay, well, fine. If you don't mind, I'm going to write it like this, though, because it's hard for me to think upside down and backwards. But the sine is 12/13. That's for sure. I just need to watch my positive and negatives. I need to watch for that. Okay. What is the missing x value? What is this? What's a? Well, a squared plus b squared equals c squared. Okay, so a squared equals c squared minus b squared. A equals plus or minus root c squared minus b squared. So that would be 13 squared minus 12 squared. 169 minus 144. 13 squared minus 12 squared is 25. Square root of 25. Square root of 25 is 5. Okay, that's length 5. This is length 5. So they gave me the sign. Great. Now I know what's going on. I'm in quadrant 4. So I think this value would be positive. I think this would be negative. And I think this is the number 13. So tangent is 12 bits. Okay? All students take calculus. All students take calculus. So the tangent is negative. So this is negative. All right, cosecant or secant. And cosecant. Negative 12. Okay, cotangent. Leave this upside down. Okay. All right. So they can give you the ratio and you can find the rest, but you have to use Pythagorean theorem. Okay. Those are the ones that I wanted to definitely go over. I don't know if we need to go over even and odd or the domain and range. So if you would allow me, I'm gonna flip through these problems really quick and see what is true. That's the last one. So it's not on there, so we can save it for next time. Sometimes you can go more than 2 pi. So this is pi. This is 2 pi. You go once more, you get 3 pi, 4 pi, 5 pi. So it's the same spot. You can just overdo it. Just overdo it. And I saw one had a negative 5 pi over 6. We did that one. 4 pi over 3. Oh, right here. Negative. So they're going this way. What happens if you go clockwise? That's annoying that they do that, but you're allowed to mathematically do that. You can go the other way. So it wants to know the location of this. It wants to know the reference number. So let me try to walk you through it. So the negative means we're going to go clockwise. Now we're going to go the other way. This would be let's do this. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. So what's the reference? Pi over 6. That's kind of awkward. So you can either take the angle that we found and then subtract that from pi. What did I say? 1, 2, 3, 4, 5, 6, 7. That's a way to like formalize it, I guess. And you can see that's what they're doing here. Oh, going the other way. It's greater than. Okay, so that's some of the ideas, but obviously there's a lot here. Okay, now let's talk about due date. So for Gracie, Hakeem, Caitlin, Michael, Sienna, and Wyatt, and possibly Micah and Josiah, it would not be the end of the world if you were a little late on this homework. Okay? So I don't know what your schedule is. I can't make it due week 8, but you could certainly work on. I'm sorry, I can't make it due the 20th. Can't do that. We come back on the 28th. Okay? For Gracie, Hakeem, Caitlin, Michael, Sienna, Wyatt, Josiah, and Micah, if you want to turn this in late or just sometime before the 28th, we're fine. So for you that stayed, if you want to turn it in by the 27th, that's fine with me. Okay, that's okay. Because I know you have finals. I haven't heard from anybody else, so I'll just assume they're fine. And I know you have finals, and I know it's the time before fall break, so I'll end it a little early. And I did what I could. I know you're doing what you can, and I know you have finals. Micah said he has 3 finals this week. So, sheesh. I hope that's not true for everybody, but that's a lot. In my heyday, I once took 3 finals the same day. I was brain dead for about 3 days after that. It was brutal. Alright, well, I'm gonna stop the recording, hang out for what questions there may be. Otherwise, I'll see you after break.